So we've seen the symbols used, and I said in the last video we're going to start looking at truth tables. Now the important thing is all of these three things are the same. So the symbol, the word and the operator are the same thing. The symbol, the word and the operator, symbol, word and operator are all the same thing, and truth tables can be used with all three. They will all produce the same truth table depending on what I input. So what do I mean by that? First of all, we need a couple of variables. I'm going to use capital A and capital B. That is standard, and what these variables are going to do, they're going to take on the values of 1 or 0 at some particular point, and we're going to apply one of the operators to them and they will give us a result. Sometimes we write R, mostly Q is the result. So that is the top line, the heading of a truth table. Now I'm just going to do a little diagram at the side here for the AND gate, just to show you what is happening. That is Q, which is the output, and this is A and this is B, and it doesn't really matter, you can have those upside down, you can have B and you can have A, it doesn't really matter. So I've got A input, B input and Q output, and what I'm going to do is put all the different variations of ones and zeros that it's possible to have as input. And when I've only got 2 inputs, there are 4 different inputs that I can manage. The first one is a 0 and a 0. So A is 0 and B is 0. So A is false, B is false. So I can write that in my table. A is false, B is false. The next input that I could do would be, let's say A is true and B is false. And I could write that in my table as A is true, B is false. And I could look at it the other way around, when A is false and B is true. So A is false and B is true. And finally, the very last one, because I've covered virtually everything, what happens when they are both true, when they are both 1, A and B is 1. And I can write that in my table like that. A is 1, B is 1, and that is the total combinations of inputs I can use when I only have 2 inputs. If I was doing a NOT gate, I've only got 1 input on a NOT gate, I wouldn't have A and B in my table, I would just have A and then a result Q. So let's take a look at the NOT gate. So this is A, this is Q, the output. A can either be a 0, so I can put that in my table, a 0, or A can be 1, and I put that in my table. A equals 1. I don't know what the result is at the moment, I'm not even bothered about it. What I'm really looking for is the structure of these tables. Now at GCSE level, I think 2 inputs is about the maximum that they do. But there is a sort of, you need to know logic up to 2 levels. And what that means is that you can have diagrams that maybe look like an AND gate, and then the output is an input to an OR gate, and that's counted as 2 levels. But I've got my 2 inputs for the AND gate, and I would need a 3rd input for my OR gate, the 2nd input of the OR gate, and I would label them similarly A, B and C. Now I'm not sure that they will put this into your exam paper, because the truth table is going to get slightly larger. The more inputs I have, the bigger the truth table, and I've done this for a particular reason. Is I want to show you what the truth table would look like, the inputs for A, B and C, because really this is pattern based and I want you to pick up on the pattern. So if I just move this up and have a truth table A, B and C for these 3, and obviously the output Q, but I'm not going to do anything, so the Q is going to stay empty for the time being. And my first one is going to be what happens if all the inputs are 0. Then I have my row in my truth table. What happens if the input A is 1 and the other two are 0 or false? And then what happens if my input is 0 and my B is true and my C is false? And finally, if you notice, what I'm doing is copying out this table here. So my A is 0 at the top, then 1, then 0, and finally 1. For my B, I've got 2 zeros here. I'm going to need 2 1s here. So this is my pattern. And for the C, I would need a 4th 0. So really what I'm saying is that I'm just looking at the A and B for the and C is always going to be 0. And I'm going to repeat that table for A and B, but for when C is 1. So repeating this table here would give me a 0, a 1, a 0, and a 1. So let me just put a line there so that you can see that the pattern is repeated. And I would repeat my B pattern. Got 2 zeros, then 2 1s, and then my C pattern. And that's it. That is all the possible inputs that can be had with 3 inputs. That's all possible combinations with 3 inputs. And the same would go for a 4th input. If I had a 4th input and a D, it would be this table with D being all 0s, and then this table with D being all 1s. So what is happening, if we take a look, let's just sort of diagonalize this. There we go. We start off with A being 0, and in the next column we double it to 2, and in the next column we double it to 4, and in the next column we would double it to 8. Let's call that D. 4, 5, 6, 7, 8. And we just keep repeating that pattern all the way down. So we take a look at the next one. Got the 1 there, 2 1s, 4 1s. It's doubling each time. So if you're unsure how to lay out your truth table, start with zeros and remember this pattern. And it really doesn't matter if you go 0 1 0 1 for the B's and 2 zeros for the A. It doesn't matter which order they're in, but try to be methodical in the way you approach it. So start off with a single 0, then 2 zeros, then 4, and keep repeating the pattern down. And that way you will produce a truth table. The next thing we're going to do is actually look at the Q. That's not a Q now, that is a D. For that table, we're going to look at the Q. We're going to do a logical operator on each one of these.